It's simple mathematics. Check it out. I'll revolve around science.
What are we talking about here?
Here we have a diagram that shows that we have two parallel lines, and we indicate that they're parallel by the arrows, and we have what's called a this is called a transversal. Okay, now basically a transversal is a line segment, or line really, that crosses two or more parallel lines. Okay, so therefore this green line is our transversal. Okay, now there's some patterns and stuff that develop when we're looking at these two concepts. Okay, so first off, notice that we have an intersection, or two intersecting lines. Okay, so intersecting lines have certain properties. If we look at this first intersection, we should see that we have an angle measure here and an angle measure here. Okay, and we notice that they should, alright, if you look at it, if I take this and if I was to fold the piece of paper or fold something along this line, if I folded them directly in the middle there, they would overlap each other. The yellow line would go to the yellow line, and the green line would go over top of the green line. Okay, so therefore if we measured these angles, they would be exactly the same. Okay, and we call that, alright, we call these two angles, the red and the red here, as you can see, alright, we call those opposite angles. Alright, so we have opposite angles, okay, are always equal. Okay, or another way of saying it is congruent. Okay, they're always congruent. Okay, so we have that there. Alright, opposite angles. And we call this opposite angle theory. Okay? So, if I take just a little diagram here, and I make a little kind of diagram in my notes, alright, I can illustrate that this angle is equal to that angle. Okay? Opposite angles. So no matter, as long as I know one, I can know the other, because they're opposite. Okay, and then we're still looking at this intersection. We notice that if we were to travel down this red line, okay, to the yellow, from the green line to the red line, swinging it open like a gate, we have a gate open this far, and then if we continue all the way around, we end up with the gate fully open, and you notice that it kind of makes a half circle. Alright, so the red and the green go together to make a half circle. We call this, okay, these two angles, alright, are supplementary angles. Okay, now these two angles, alright, they share, notice that they share, alright, they share this one common line, alright, and they share they actually share this yellow line. Okay, so they share an arm or a leg of the intersection, and they also share the vertex. So supplementary angles share an arm and, alright, and a vertice. Okay? Now, these angles make a half circle. So we know that a half circle is equal to 180 degrees. So therefore, supplementary angles add to equal 180 degrees. Okay? Alright, so they make a half circle, so therefore we end up with 180 degrees. We call this angle theory supplementary angle theory. Alright? Okay, so that's in that one intersection. Okay? Now, because of these two, because of this theory and this theory, when we mirror, all right, so we almost mirror with the parallel lines. These lines are mirrors of each other. If I were to take again a piece of paper, all right, and if I drew this out on a piece of paper and I folded this directly down the middle here and folded it over, you would see that these two parallel lines will fit exactly on each other, which then also makes these two intersections fit exactly on each other. Okay, so if we fold them, these two intersections fold on top of each other, and therefore these two intersections, this intersection and this intersection, are congruent. Okay, which means that they're the same. So we have some angle theories that fit into this two parallel lines in a transversal. All right, so the next one we looked at, all right, has to do with the fact that we look at this angle here, all right, and we fold this over so that the intersections are overlapping. We'll notice that that angle is actually the same as this angle. All right, so we end up with that, which you can see that we end up with a pattern that looks like this. All right, and we call that the F pattern. Oh, before I get going too long, I should do a little diagram of a sat. So if I have an intersection, oh, boop, 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 boop. Okay, I'm going to make that a little straighter. Okay, so let's make that straighter. I'm going to straighten her out there. All right, and then if I have an intersection, all right, I'm just going to label this one and this one together equal 180 degrees. All right, so, okay. We can also call that, these ones, supplementary angles, can also, sorry, before I get going, can be adjacent angles. Okay, adjacent angles. Adjacent angles. Okay. Okay, and therefore they add to 180 degrees. Okay, adjacent angles. So we have supplementary and adjacent are the same. Okay? All right, so then let's getting back to this F pattern, sorry. These angles here, okay, are called corresponding. Okay, and we describe them as they're on the same side of the transversal. Notice here, the purple are on the right-hand side of the transversal. So, they are on the same side of the transversal. Okay, and they're formed by two parallel lines. Okay, so formed by two parallel lines. Okay, these make what we know as a F pattern. Okay, so they form an F. And corresponding angles, All right, corresponding angles. I'm just going to add this note over here because I'm out of room on my canvas. All right, so these angles are equal. Okay, makes sense? All right, so that's corresponding angles, and so those are angles, and we have a bunch of those going around. If you can see, I could have a corresponding angle here and here. I can have a corresponding angle here and here, okay? And then I can have a corresponding angle here and here, if you will. Okay? So those are called corresponding angles, and they're equal as well. Parallel line here, and I'm just going to make a transversal. Okay, and I'm going to ensure that these are parallel by drawing the lines. Okay, so now we're going to look at this one, a slightly different diagram, but it's the same. My transversal is here, splitting the two parallel lines, etc. Okay, so then after the corresponding angles, we started to look for other patterns. All right, so we looked at these two angles here and how they are also equal. And this one formed what we called, it was a Z pattern. Okay? And we call these angles alternate angles. And these angles are on opposite sides of the transversal. Okay? Created by two parallel lines. Parallel lines, okay, and are equal. Okay, and we have two types. All right, so we've got two types. We've got IATT, which is interior, so the red. All right, so I'm just going to draw a little diagram. So we've got our two parallel lines, our transversal, and we end up with IATT, which are interior. All right, and then we have EATT, which is exterior. All right, and we end up with these two. All right, so kind of on the bottom and the top of the Z. All right, so these ones are, let's go with the red. The red are interior, and the blue are exterior. Okay, and these angles are equal, so blue and blue is equal, and red is equal. Okay, so we can solve problems using that. All right, and then from there, all right, we looked at the last kind of angle theory with these types of diagrams. We looked at co-interior angles. Okay, and we saw that in our diagram. We saw that co-interior, if we looked, we have an angle here, and then we have the angle in red. All right, and we decided that if we looked at the opposite angles, and we discovered that this angle here is equal to the one underneath. All right, and we said that, okay, these two angles add to 180 degrees, and we know that because of corresponding angles, this would be a yellow angle down here too. If we look, we've got red, yellow, and red, yellow. All right, and we know that red and yellow on the top intersection add to 180 degrees because they're supplementary, and red and yellow down here add to 180 degrees because they're supplementary. Okay? We notice that in the interior we have a yellow and a red, and therefore they must be supplementary as well. So co-interior angles, all right, are angles that share the same part of the transversal. Transversal are on the same side of the transversal, and because they are supplementary, they therefore add to equal 180 degrees. Okay, so we have alternate angles and co-interior angles here, and the co-interior angles, all right, they make a C pattern. So if we kind of drew it out the way it would look like, okay, this is parallel, and these two lines are parallel, and then we have a transversal that makes a bit of a C there. All right, so if we look, we have this angle, all right, and then we have, what did I use? Yellow. All right, so then I use yellow here to say that those two angles equal 180 degrees. All right? So those are all the angle theories dealing with two parallel lines, transversals, and intersecting lines. A well-known shape that you know of. All right, we know that this angle, and this angle, all right, if we call this A, B, and C, we know that A plus B plus C has to equal 180 degrees. And that's because these are interior, angles of a triangle, okay, otherwise known as IATT, interior angles of a triangle theory. Okay? At the same time, if I draw a four-sided shape, all right, we notice that we have, if I were to draw a line across here, all right, you end up with two triangles. All right, so therefore, two triangles, 180 degrees must equal 360 degrees. So that means that the interior angles of a quadrilateral, so if we call this A, B, C, and now D, A plus B plus C plus D must equal 360 degrees. That's not very good. I'll redo that one. Equals 360 degrees. So we end up with interior angles of a quadrilateral. Theory, right? So IAQT, all right? Interior angles of a quadrilateral. Okay? So those are all the angle theories, and now we're going to kind of put a little bit of practice into it. So I'm going to go ahead and just open a new diagram here. No, and I'm going to go. All right, so I'm going to draw a line. I'm going to make a line parallel. I'm going to attempt not to make 90-degree angles, so I'm going to call a transversal here, and I'm going to put a second transversal maybe maybe right, let's go with here. All right. Okay. So we have these shapes, and you can notice I have created some shapes and some regular old lines and transversals. Okay, now suppose that we have one angle here. Suppose that we have one angle here. All right, that has a value. Let's see, that's probably about a 45. We're going to say a 45-degree angle. Okay. All right, so if we're given this, now we should be able to solve problems knowing some of the angle theories. Okay, so I'm going to know that this angle, okay, has to be 45 degrees. All right, so this one is 45 degrees. So we're going to call this A, and we'll call this B. All right, so angle A is equal to 45 degrees. Therefore, angle B is equal to 45 degrees. Why? Because of OAT with angle A. Okay? So I've proven that one there. All right? Now, if that's A, B, I need some C's and D's. So maybe I've got angle C here and angle D here. Okay? So now I should be able to figure out angle C. So if I look at angle C is equal to 180 degrees minus 45 degrees, all right, which is 135 degrees, because, how do I know this? Because it is set with angle B, all right? So therefore, that angle is 135. So angle C is 135 degrees. All right, now if we look at angle C and D, all right, now we have lots of information to get D. We can either find it with SAT or we can find it with OAT. So angle D, all right, is equal to 135 degrees. Why? OAT with angle C. Okay? So now we've got that. Okay? Now, if we look at, we got A, B, C, and D here, we have E, F, G, H, okay? We know that, all right, we can figure out these ones too, all right? We should be able to figure out that these two are equal, all right, because if we look at A and E, they make the F pattern. All right, so if you look at it, these make the F pattern here, right? Okay, we can see the F pattern, and that is corresponding. So if I wanted to write that, angle E is equal to 45 degrees. Why? Because of CAT with angle A. All right? So then we have 45 degrees here. Okay? Makes sense? Now, I can use that same theory. A and G are equal because angle G is equal to 45 degrees. All right, now I don't want to repeat theories, so I can go why? Because of EAAT, exterior alternate angles, right? The Z pattern. So I have the Z going here, and they're on the exterior of the Z. So these would be EAAT, all right? So 45 degrees, so that's G. All right, And now I can kind of do, I can find F a couple of ways, but I'm going to find angle F is equal to 180 minus 45 degrees, which I already know the answer to that is 135. All right, why? Because it is co-interior angle theory, or CIAT, all right, with angle B. All right, so
It's simple mathematics. Check it out. I revolve around science.
What are we talking about here?